Awesome. We are live now. Let's start the recording here. Okay. Yeah, maybe we can just give it another 2 minutes. But yeah, I don't know if you saw the project submissions in the project/teams tab, but I think a lot of people are specifically working on Mechanistic track. So yeah.
That's awesome. I'll take a look after this, but that's really exciting.
Yes. I know, like, we also, I think there's been a lot of changes though to the whole API since November. Even the look.
Yeah, yeah. It's mostly been like a UX refresh, and then we added support for a few new models, but the interface should be pretty much the same as
Uh-huh.
um, when we used it in November. And the feedback from the first hackathon was really helpful for us to like refine the product and then
Yep,
launch it publicly.
yep, makes sense. But yeah, I think we can just give it another minute before we start. But for everyone joining in, thank you so much. Feel free to use the chat and let us know where you're joining in from. Yeah, I can hear Myra though. So yeah, someone said they couldn't hear you, so I wasn't sure. I think it's Discord. Discord loves to mess around with people, I feel.
Okay.
Yeah. Okay. Nice to know you just got
I
back.
love pickleball.
Awesome. I think we should be good to start, so we can just do like a presentation and then a little bit of time towards the end for Q&A, if that works.
Awesome.
Yeah. I'm
That
gonna
sounds great. So
Yeah, I'm gonna leave the stage, but you can just feel free to share your screen, and it's being live streamed as well.
that sounds great. So, hi everyone. Thank you for joining. Really excited about this hackathon in particular. And just as a sort of heads up about the content of this talk, I'll do a quick intro about myself, and then I will uh, talk a little bit about how I ended up working in AI interpretability, kind of my journey into the field, and then I will give an overview on what we do at Goodfire, which is the company I'm helping build right now, which is an AI interpretability research lab. This talk hopefully will be around like 20 minutes, and then I'll leave some time at the end for questions. Cool. So let me share my. Can everyone see my screen? Hopefully. Okay. Okay, I'll get started. Hopefully it shows up soon, but yeah, so hi, I'm Myra. I'm currently a founding product manager at Goodfire. Goodfire, as I mentioned, is an AI interpretability research lab. And before Goodfire, I spent some time at Stanford doing a joint MBA and MSCS program. And the reason for that was I was really exploring my interests in AI research as well as startup building and entrepreneurship, and trying to think of the best way to kind of merge those two interests for my career. And then before that, I started my career as a software engineer and then eventually product manager at Two Sigma, which is a quant hedge fund based in New York City. And there I was helping build sort of ML model infrastructure platforms. Some fun facts about me: I am a New Yorker, so I spent 7, 8 years of my life there, but have been in California for the past 3 years, so slowly becoming a Californian. And in my free time, I love reading fiction, practicing yoga, journaling, and cooking with my friends. So, yep. Yes, let me try. Does that work? Okay, great. So I just wanted to talk a little bit about my path into AI interpretability. Hopefully it's interesting or helpful for anyone who's also thinking about working in AI safety. Um, so how it all started was kind of back in 2018, 2019, when I was studying computer science for my undergrad. There we were learning about machine learning models, and they were really exciting, seemed a lot like magic. You had these model architectures and then a lot of data, and somehow these models learned interesting and meaningful patterns for downstream tasks. And got really interested in it, but also started to see these articles come up about how these models could exhibit bias against underrepresented populations, whether that's women or BIPOC communities, and uh, started to become a little bit concerned and interested as well in thinking about how to solve this problem from a research angle and from the angle of developing these models as an engineer. And so I think there's the claim that models are just like humans and that they learn from data that exists out on the internet, and so it's difficult for them to not exhibit these biases or have the same problems that humans might have. But also, these models will be used at scale across lots of different use cases, and kind of there's this feedback loop of training on model data as well. So it seemed like a really pressing problem that would just kind of proliferate if not addressed. And so I became really interested in this, decided to leave my job and think about it full time while at grad school. And during that time, everything happened with Transformer paper coming out and ChatGPT and sort of this burst of activity with large generative models. And that was really exciting to me, but also a little bit concerning in that these models became increasingly complex and large and black box. And I, started to think about what were the repercussions of not truly understanding how these models work. And that's how I got into kind of thinking about AI alignment more broadly, and thinking about the different sort of technical areas of research that we're trying to solve this problem. And one of the most interesting areas, in my opinion, was mechanistic interpretability, which is kind of the field of reverse engineering neural networks, really trying to understand how they work under the hood, why they, exhibit the behavior they do by truly understanding sort of like the weights and the circuits and the features within the model. And at the same time, a lot of exciting research was coming out. Anthropic's paper towards monosemanticity seemed to show that, there was a lot of promise for interpretability working for increasingly large and sophisticated models. And so I kind of decided, this is like one of the most interesting, exciting problems to be working on in my career. And also at the time was really interested in startups and trying to build an organization around solving this problem. And that's how I came across Goodfire. And I'll talk a little bit about Goodfire, which is where I'm at right now, and we're helping sponsor this hackathon. I'm really excited about, continuing to get more and more people involved in alignment work as well as interpretability work more specifically. So we are a research lab trying to address like this fundamental problem that I mentioned, which is that, today large generative models are really, really smart, really sophisticated, but they can often also fail on basic tasks. There's like a lot of examples of this on Twitter that I'm sure you've seen, which is like count how many R's are in the word strawberry, and the model gets it wrong. So, it just goes to show that these models are incredibly sophisticated, but they can be unreliable in certain cases, and they're really challenging to edit or debug because of their black box nature. They're also really hard to interpret. They're this kind of giant architecture of weights and connections between nodes, and are not human interpretable from that perspective. And we really think at Goodfire that there's a lot of promising techniques out there, like fine tuning, prompt engineering, or kind of accumulating a more curated data set. And these are all ways that we've tried to get models to do what we want them to do. But we think that these are in some ways band-aid solutions that have a lot of off-target effects as well. And that, really understanding how a model works and being able to sort of perform brain surgery on the model is kind of the key to unlocking safe and aligned AGI. So some examples, I'm sure many of you have seen the recent paper from Owain Evans' research group that showed that fine-tuning GPT-4.0 or 4.0 on a narrow task of writing insecure code actually exhibited broad misalignment in the fine-tuned model. And kind of goes to show that fine-tuning, while incredibly effective at many things, is still widely misunderstood and or not misunderstood, but difficult to understand and difficult to really predict model behavior from processes like fine-tuning. And then prompt engineering, this is a often trial and error discipline. People experiment with lots of different hacks to try to get models to do what they want. And then it's kind of like accumulated knowledge of people trying to share the best tips and tricks from prompting. And then, in failure cases, oftentimes companies will pay human annotators to curate data sets that exhibit the behavior of the model that they want, but this can be very expensive and time consuming and sometimes even impossible. So at Goodfire, we really have this really ambitious and kind of exciting vision of the world of model development, and where if you look inside the mind of an AI model, you can really understand and intentionally edit the way that it's designed. And we've called this process neural programming. So essentially being able to reach into a model and actually edit its neurons and the specific parts of the model that you want to edit for whatever downstream task. And in the last year, as I've mentioned, there's been a lot of exciting research in this field. We've really hit an inflection point in neural network interpretability, at being able to extract sort of monosemantic concepts, and also extending a lot of the promising techniques from toy models to larger models as well. So with Ember, we support Llama 3.18b as well as Llama 3.37db, which are frontier open source models. We're also doing work at Goodfire to train an SAE on R1, which is a model of 670 billion parameters, and are continuing to extend a lot of the research onto more and more powerful and kind of super intelligent models. And all of this exciting research has enabled us as a company to build kind of the first neural programming interfaces, or NPIs as we call them, to really understand and edit AI. So how does this work? There's kind of a three-step process. The first is to extract model features. So this means actually going into the model and pulling out kind of meaningful concepts. And we call these concepts features, which are kind of patterns of neurons within the model that represent like meaningful semantic concepts. So the way we do this, we train an interpreter model to extract model features from the target model, the base model. And this interpreter model, in our case right now, is sparse autoencoders, which is kind of the most promising direction in the literature. And then once we have those features, we need to label them with labels that humans can understand. And this is the kind of practice of auto interpretability, which actually one of our team members, Nick Camerata, helped pioneer at his time at OpenAI. And this is trying to actually map human labels onto the features so that we can interact with them in a meaningful way. And then third is actually interacting with the features directly and editing them. So adjusting the strengths and the weights of the features and achieving sort of the intended behavior that you want from a model. And neural programming interfaces really unlock a new way of using AI models, and we think will unlock a lot of interesting use cases as well. So this isn't just limited to language models. Really, it works on any AI model, and we've experimented at Goodfire with LLMs, with Goodfire Ember, which many of you might try out this weekend. We've also worked with image models and recently collaborated with Arc Institute on their biology model as well. And by using an MPI, you, as I mentioned, extract these features. You also extract kind of a control panel of features so that you can actually tune weights continuously on each of these features. And in doing so, you can use AI models in completely new ways. So for instance, in large language models, if you tune features, you achieve, in many ways, zero data fine-tuning, which is meaning at inference time, you can change these features and immediately change model behavior. For image models, when you have features, features in this case can be the things that the image model has learned to understand. So it could be, cats and dogs and flowers and grass and things like that. And if you change these features, you can actually edit images in a state-of-the-art way. And then for biology models, the features that you extract with an interpreter model or a sparse autoencoder are meaningful biological concepts. And then you can actually edit those and tune those to do things like targeted protein generation, which is something that we're working on as a team with Arc Institute. I will skip through this case study right now just for sake of time, but happy to talk about it if anyone's interested in biology and biological models. But quickly, I'll talk a little bit about Ember and how this fits into the mission and vision of Goodfire. So we built Ember to be a neural programming interface for frontier open source language models. We support 3.1 AB and 3.37 dB. As I mentioned, you can use Ember to understand the features that a model is thinking about when it's generating output, and then you can actually edit those features directly or steer those features directly to achieve some intended behavior. And we're really excited about, research on both understanding what a model has what a model is thinking about when it performs certain tasks, but also steering is still kind of an evolving feature or an evolving research area, and we're still trying to figure out the best ways of doing steering. So really excited to see how people in this hackathon use steering to achieve interesting performance, whether that's beating benchmarks or trying to adapt the model to a very specific task. And in terms of real world impact, we're working with a couple enterprises, including Rakuten, to use Ember to unlock interesting latent intelligence of the model that they can then use for downstream tasks like PII leakage, jailbreak robustness, hallucination reduction, and many other things as well. And really, really excited since the last time we partnered with Apart for the first hackathon. We've seen a growth of usage in Ember, hundreds of independent researchers who are using Ember to do fundamental interpretability research, and we hope that many of you will continue this trend and continue engaging with the broader interpretability community through Ember. And then a little bit about how we see the future and the kind of moonshot vision that we're building towards at Goodfire. We think that in many ways there will be a new post-training paradigm that can be enabled by interpretability. So post-training right now is, you have the pre-training step where you create a base model, and then post-training is when you actually get the base model to exhibit the behavior you want, whether that's being a helpful assistant or being a coding assistant or whatever iteration that you're interested in. And existing post-training techniques are like RLHF, which many of you have heard of, or RLAIF now. And we think that there's a way that this is enabled by interpretability, which is that, you have this powerful base model, which has a lot of latent knowledge and intelligence. But if you could imagine training that base model to exhibit the behavior you want by actually locating the internal features that are important to the task, whether that's being a helpful assistant, and then editing those features directly. And then this kind of will enable a new feedback loop of training that is fundamentally more interpretable and more understandable and more efficient as well. And so this is kind of our long-term research direction. We're a ways away from it, but have a lot of exciting signal that this is certainly possible, and we think will be a really exciting new way of doing model development. And we're also thinking about extending this research to pre-training large models. So you can imagine building inherently interpretable model architectures that are just as powerful and capable as the transformer architecture. And also really trying to understand what happens to a model during pre-training. How does the data, this huge amount of data, actually become, meaningful internal concepts and knowledge for the model, and trying to understand how that works in order to make pre-training more interpretable or even to build more interpretable model architectures from the ground up. So I'll stop here. This is a little bit about us at Goodfire. I will also plug that we are hiring. We are really expanding the team. We're looking for research scientists, research engineers, and as well as just any talented folks who are excited about interpretability. So if you're interested, please check out our careers page or reach out to me. We would love to chat. I will stop here for questions and happy to revisit the slides too.
Yeah, thanks a lot, Myra. Such a insightful talk, and also, I love the fact that you gave us a background about how you came into AI safety, which I think is it's somehow like very similar, but then also really like what drew you in. And I think we keep hearing these stories like over the weekend, but it's truly very inspiring that most of us like changed our, yeah, I guess like career paths to be in this right now. And yeah, I am just gonna ask folks to put in their questions, because I think a lot of folks had questions about the using the Ember API as well. So feel free to add comments and questions in the chat. But yeah, I think one question that came up on the help desk was also around like most folks, if they didn't see the credits, then they probably just need to create like a account and then it would automatically appear, right? Maybe there's just a disconnect there with the
Yeah,
account.
so you should create an account first and then make sure you filled out the requests for credits form.
Mhm.
I think Archana, you sent that out at
Yeah,
some
yeah,
point.
yeah, yeah.
Um, and then you should have credits. I will, after this call, go through the list and make sure everyone who doesn't have credits on that form gets the credits. But just as a heads up, everyone starts with $5 of free credits. So um, like you should be fine to get started. It's just that we give you a couple extra credits in case you want to spam our API.
But yeah, thank you so much. I know like it's a little like extra work, so so sorry we put that on your plate
No,
as
no
well.
problem. No
Yeah.
problem.
I I think we have like a couple questions here. So one is like, what would the workflow look like as someone building like an AI product? When should one start using Goodfire? Yeah.
Yeah, it's a great question. So, as I mentioned, a lot of the users right now are researchers. So, we're still early days in trying to embed Ember in like an AI, a typical like kind of AI application product workflow. But as I mentioned, we do have some enterprises um, using Ember. So, for instance, the workflow is kind of like you can either use our out-of-the-box supported models, Llama 3.1 EP or 3370B, or you can, we also support enterprise contracts as well. So we work with custom models that these enterprises are using. And for the case of some of the companies we're working with, you can imagine they want to work on creating a model that is more robust to jailbreaks. And so they'll use Ember to extract the features that are like kind of most activated when doing jailbreak detection, and then tune those features to make the model more robust to certain benchmarks on that they care about, and
Mm-hmm.
then use um, adjusted model variant as their new model in production. So that's kind of the workflow for enterprises using Ember. And as mentioned, a lot of the people using it right now are researchers. I think someone asked, other than independent researchers and students, there's also like other labs you can imagine. So
Yeah.
Apollo Research, Hayes Labs, other kind of AI research labs are using Ember quite a bit to understand how models work. And then, as I mentioned again, enterprises and research institutes that are building their own models and want interpretability. So Arc Institute is another example.
Got it. Mm-hmm. Mm-hmm. Yeah.
Um,
I
I
think.
can just move down this list if
Yeah. Yeah.
that's
Yeah. Go
helpful.
ahead. Yeah.
I can say more about the Evo 2 work. You should check out our Twitter. We did a thread there, and also check out the paper as well. We published a paper on bioarchive with the Arc Institute team. Um, so essentially, what we did with them is they have this biological foundation model, which is state of the art um, in the world of like DNA foundation models. And they were able to use this model to kind of predict interesting and meaningful DNA sequences, but didn't understand how it worked because it is encoded in DNA and which is not fundamentally human interpretable. And so we extracted features using our sparse autoencoder approach that Evo 2 had learned, and we're able to map these to existing annotated concept tracks to kind of map towards the ground truth of existing biological concepts. And we're able to extract a lot of meaningful concepts, and also are now looking to annotate previously unannotated uh, DNA sequence regions using these feature activations. And we're also investing in a lot of research to understand how to steer
Mm-hmm.
in a
Mm-hmm.
very targeted way, being able to actually turn up certain biological concepts like alpha beta helices without affecting other properties of the protein or the sequence. And that's
Interesting.
still a very evolving field of research, but we're really excited about the direction. We see a lot of interesting signal here, and we'll hopefully be publishing another paper with them very, very soon.
Yeah. That's very exciting.
How does the reasoning component of R1 affect the SAE training process? That's a great question. So, for SAE training, we need to curate a data set that's actually representative of the model's pre-training data set. And for R1, we are generating reasoning traces following a similar approach to how the model was pre-trained. So that's kind of the SAE training set, but then the actual SAE training approach is very similar to how we've trained other SAEs as well. And we're really excited about this work. I think we'll have a paper, our blog post or paper published on this quite soon. What do you think of the criticism that SAEs focus on far too fine-grained concepts? Yeah, I think there's a lot of very valid criticisms of SAEs, and we're certainly not, saying that this is the end all be all for interpreter models. It's certainly the most promising approach we've seen so far and has extended really well across different domains. And so that's what we're investing in a little bit now. But we actually also have a team now based out in London that is helping build out what's it called? Attribution-based parameter decomposition, which is kind of another approach to uh, interpreting a model and breaking down meaningfully semantic concepts. And we think that there's going to be a lot of evolution here in what the right way to do um, model interpretation is. and are really excited about that direction. If people want to check it out, I'll send the paper in this channel.
Yeah, thank you so much, Myra, for like giving all the resources. It helps so much. Yeah, I think like mm, again, like I just really want to thank you for taking out the time today and doing like the
Of course.
session. Yeah, and feel free
Yeah,
to check out like the project slash teams as well. People are like throwing ideas there constantly, so if you
yeah,
do have the time, I like yeah, if you want to comment, just feel free to do that. And yeah,
sounds
we're
great.
really excited for what comes out tomorrow.
Yeah, really excited. And please reach out to me if you have any questions. I'm Myra at goodfire.ai. And again, we're hiring, we're growing very quickly. Really excited about getting more and more people, smart people, in on the mission. And yeah, really enjoyed meeting all of you, and good luck with the rest of the hackathon.
Thank you so much, Myra.
Bye.
Bye bye. So yeah, we are just gonna give ourselves like a 5 minute break before we start with the next session. So you can still stick around here, but let's just give ourselves a bit of a break. But again, like really wanna thank Myra for taking out the time today. But yeah, we'll be back.